Good morning, good afternoon, and good evening to all our attendees. And we thank you for joining today's webinar around Agentic Document Extraction. We're going to be discussing some great industry use cases. Today's host is our product manager who has a deep knowledge. I just had a great training session with her yesterday, Fatima. And my other colleague is Andrea. She is our senior machine learning engineer who I work closely with. You have a deep well of information with both of them. So we will be moderating this today. Again, we encourage all questions. Just please use the Q&A function. With that, Fatima, take it away.
Thank you, Adrian, for such a warm introduction. I will be sharing my screen. Adrian, can you confirm if you are able to see the screen?
Yes, it's coming in very clear.
Okay, perfect. So I wanted to start by giving an introduction about like what we are trying to solve here. When we started off this year, we saw a lot of like users that we had struggling with like different kinds of documents. Even like someone who had a very structured document processing example, like invoice processing, they will get varied amount of like documents which they are not able to process by like one system. And so we set out to like build something that like quite works for like all different kinds of documents and converts them into like structured information for downstream use cases. And the whole purpose for what we are building is to have it as accurate as possible, like getting the best quality data upstream. So you should be able to like get insights or actionable items downstream, which are way accurate than other systems. Yeah, for today, I will go over like what ADE is, or Agentic Document Extraction, our product is. Some of the use cases in insurance. I will show around like the playground and how to get started with like testing your use cases in the playground, and orientation to the API and documentation, because we are essentially an API first product. The playground or the visual playground is just used for testing and initially getting started. And then I will jump to hosting options, security, etc., to like get this to production, get the product into production on your side. Cool. A little bit about me. I am Fatima. I'm the product manager here at LandingAI, working specifically on document extraction. So if you have any questions, etc., I should be able to help, as well as Andrea. And I'm always welcoming your feedback too. In my background, I have had computer vision experience working on building vision models for localized solutions, but now shifted over to document extraction and building and bringing in the vision expertise from previous experiences. I also have a little bit data analyst background, where I was manually cleaning the upstream data to make sure that the modeling from the machine learning side is right after the data is cleaned and processed. Cool. Little bit about LandingAI before we get started. We are document AI company. What we are trying to do is like build a solution that works for the new era, where the downstream processes uses a lot of LLMs or language models or semantic models to understand and make sense of data. So this data that is to be extracted from documents need to be like in a format that is supported quite well with downstream new tools that are coming out, and also should be like extracted in such a way that the semantic meaning of the data is preserved from the documents, so that you will be able to like effectively work with the LLMs downstream. We are founded by Dr. Andrew Ng. He is well known in machine learning and data science space. And he has been a proponent of agentic AI, where he wants the tools to work in combination with like different systems, so that like one specific solution is solved using the right tools for that solution. Under his leadership, we are able to process about 1 billion images and documents till now. And we are looking forward to scaling even further. So going into introducing the agentic document extraction product itself, we are API first product. We have multiple APIs to do the right transformation of data from the documents into like the expected downstream output. What the APIs do is like take in your documents and then use reasoning to examine like what it needs to do with that document. How does it need to chunk it or layout, extract the layout, classify like individual components inside the document, and then convert it into like the most meaningful markdown or JSON for downstream task. And I will go into some of the features of this API soon, but let's just first understand like where this can be useful. This is useful majorly in two cases. First is field extraction, and then the second is the preparation for RAG, which is retrieval-augmented generation. For field extraction itself, like that means is to extract like entities or fields and converting the documents into like a very structured format. The examples of this could be like if you have an invoice or claims forms, you want to extract like the name of the person who is involved with the claim, or if you want to invoice from the invoices, if you want to extract the invoice number, etc. Very specific information can be extracted from these documents. Or like if you have more of like policy documents or outlook of the industry, etc., those kind of like more contextual documents, it can be converted into like a markdown format, which is best suited for retrieval augmented generations with LLMs downstream. Yeah. And so these are more of like structured documents where you will want to extract structured information from this document itself. And these are the cases that can be used for field extraction. This includes like ID documents, various forms involved in insurance processing, and various like supporting documents that the users have provided along with it. Yeah, this is similar to what I was explaining about field extraction. Like if you have a multitude of documents like such as invoices and you want to like perform transformation on all of these invoices to extract the document data in a structured format to store it in like database or make a model or like a processing out of it. In terms of RAG applications, this is where we see more of like documents which are policies or guidance or understanding of the market. This could be used for, let's say, underwriters who want to like find a specific policy around like a specific claim. They can find it out using like the RAG applications that are built downstream and which needs input of like documents where this kind of like information is stored. In terms of features of the API, the first thing that we have with agentic document extraction is that it works out of box. You do not require any kind of fine tuning for your document types. And so you can just quickly get started with like any kind of layout documents that you have, any kind of like text or elements that you have inside the documents. You don't need any kind of training to get started with both of our APIs. In terms of like the layout itself, what we do is like we detect like different chunks or like components of the document and then order it. I will explain that more into the playground, but look out for the layout part as well in the playground. Apart from that, one of the most important feature we have is visual grounding. So we provide like precise location of where every component is located inside your document, inside the page, and where exactly on the page. We provide like the bounding box coordinates along with like the chunks that we are outputting. What this helps is like to maintain audit trails. Let's say you are building a RAG application downstream, or even you are building an entity detection system downstream. If you have a human in loop and they are detecting like they are extracting certain value, let's say like the invoice number, they will be able to reference it back to the document and the page itself so that they can verify if the extraction is correct. This could also mean like in RAG applications, if the user has asked a certain question, not only the LLMs downstream that you build will be able to reply to the answer to the question, but also exactly pinpoint where it found the information from in the document. So you have like a source of truth for every answer that the RAG chatbot will be providing. And then one other thing is schema-driven field extraction. So we are able to like convert all the information into a structured format, and this structure can be defined by you. It can be like 1 or 2 fields from the document, or it can be like 30 or 50 fields from like a large document as well. You can define the structure clearly, and we will respond based on the structure and the identity types that you have provided. And lastly, like all of this is presented as an output in JSON, like a very structured JSON, which has like clear markdowns for each chunk, clear grounding for each boxes, where exactly it is located, as well as like the chunk references for you to like be able to like quickly connect and start your own application start building your own application on top of this. Yeah, I will go into some of the use cases in insurance industries before I go and show them in the playground on how it works. What we have seen in health insurance, life insurance, accident claims, etc., is that you have like a whole process of like applying for the insurance claim, underwriting and review of those claims, policy issuance, if the policy is being issued, if the claim is being processed, the administration for force administration and claim submissions and adjustment. And then like maintaining the audit trail and compliance of all the policies that have been filed. And this can mean multitude of documents. From application, you can have health insurance application form, identity proofs, from like policy issuation, it can be contracts, summary of benefits, etc. And this will differ a lot based on countries, but it's just that means that every step of the process involves dealing with a lot of documents, be it structured or unstructured. Similar with auto insurance, you will have application forms, etc. But like when you have the claims handling, you will have a lot of unstructured documents such as police report, towing receipts, witness statement, medical bills, etc. For homeowners insurance as well, you will have like more unstructured documents and forms, etc., that is being submitted with claims handling. Yeah, so the point of this is to like indicate how much documents are involved while processing processing an insurance, and how many different teams inside the company will be like dealing with this kind of unstructured as structured documents. And these documents come with a lot of its messiness. Most of them have a varied layout, like even something as structured as invoices does not come into the same layout. So you need a API or a product which can deal with like multiple kinds of layout at the same time without requiring a lot of effort from like going from one set of documents being processed to the other set of documents. It can also mean like the variety on scan pages, like something that is like a poorly scanned document or like a photocopy of the document itself. It can have handwritten notes along with the digital parts of the fonts, etc. And it can come in multiple languages. Consistent formatting is also not really present. And sometimes like have rotated documents. Inside the document itself, you will have multiple components as well, like checkboxes, signatures, radio buttons, etc. We want to deal with all of these issues and the messiness and make sure that all of these kind of cases work with our solution. Let's see some examples to get started. You can go to va.landing.ai to get started and then click on Agentic Document Extraction. This will lead to our playground. As I mentioned here, you can test out like multiple documents before you get started, so you can see how it performs on your documents. I will start with like a simple life insurance application scan. So this is like a made-up document with handwritten information. It has some radio buttons, checkboxes, etc. And just overall a general scan document. And what we do here is like first detect the layout. So this is what I was talking about when we detect the layout. We kind of group all the information into relevant chunks. So the information that needs to be together is connected. So let's say if you have the client name like here, and Andrea's like the name of the client itself, it's far away. Like it is still connected with like one bounding box. So all the information that is part of the one information is connected together. And then all of this information is ordered in the right way. This is like a simple document in terms of ordering, that is like it needs to go from top to bottom. But I will show you some examples where this ordering is super important for you to get meaningful data downstream. Once we do the layout detection and ordering, we classify each of this component. For example, here this is classified as logo, and these are classified as text. I will show you more examples of like other classifications as well that we can handle. And then all of this is extracted in Markdown format. We offer a Markdown and a JSON, which is more structured. Like we have the Markdown as well as the bounding boxes or the grounding for each chunk inside the document. And as you can see, it is able to like detect all the handwritten stuff along with the digital text. And then when it comes to checkboxes, it's able to identify that this is a checkbox, even though it's a circled no, and then classify that this is ticked as no in terms of like the answer. If you see like more here, the text is written above and below the line, it's able to detect it completely as the answer. Here it's just it didn't have a radio button or the checkbox, but if the user just wrote no, it's still able to detect and like correctly extract that. And in JSON, we have the exact location of bounding boxes and the page number if you have multiple pages. I will show you some more examples and how this works with like different other files. Let's say that if you have a very complex table, for example, here this table has multiple grouping or merging on top, and it's like a really wide table with like a lot of data and icons, etc. We will be able to detect this whole chunk as a table, mark it as a table, and extract the results in an HTML so the table structure is maintained, along with like any check mark indications, etc. As for other receipts or like towing receipts, etc., which could be a photocopy of the document, we are still able to detect all the chunking, all the grouping of information, and then extract it as expected in like from the documents. This is another photo of the towing receipts where it's like it's taken from far away and then also it's tilted, but we are able to detect the chunks and then extract it as needed in like text or table format. Let me show you some other lab test results which can be involved with like medical insurance claims. For this lab test results, we have the top part where it indicates like what lab it is from, but then we have like some scan codes which are detected as scan codes so that you are able to like extract them if you need for any downstream scanning of those codes itself. We have another table here. This table doesn't have any grid lines, but we should be able to form the correct grid lines and as well as rows and columns to extract them accurately. Here we have another chunk type. This is called an attestation, where if there is a signature present, we are able to detect this there is a signature as well as it is signed. If it is not signed, it will also say like it's not signed. This is another example of a lab report where we have attestations and scan codes. I also wanted to show this example. This is a complex table. It has 3 tables inside. One is this one. The other one is this big one. And then there is a small one. Without any kind of grid lines or indication of like there are multiple tables inside this document, we are able to detect all these tables and then form the correct grid lines. Along with it, we are able to detect the 2 rest of the tables as well. And the last notes referencing the tables above with the superscripts. And this is an example for multi-column format. Here you have, this is more of a market report on insurance industry. You have to like first read this column and then go and read this column. We are able to detect that all this information is part of one column, so they will be ordered correctly. So once you ask a question related to like technology risk, if there is a context present on the chunks above and below, it should be able to like connect them meaningfully and provide you an answer for the RAG application. It's also able to detect figures, charts, etc., and then extract the information that is present from those figures as well. I also wanted to show you some ID examples. We detect them as cards, and then we extract all the information in a key value pairs. This is an example of ID document from Switzerland. We are able to detect different languages here, like their language is still like in English format, but we are able to detect all the codes, like code is CHE, etc., and extract all the numbers from bottom. If you have documents in different languages, such as this one, it's able to extract not just the English part, but also like able to extract like all other languages from the documents. Coming to another use case where I want to show you some of our capabilities of extracting and grounding the information and what we mean by it. We have this policy comparison image where we are comparing 3 policies for different ages as well as like premiums and cash values. First, we will go and parse it. Parsing means to extract everything from the document. And once the parsing is completed, what I will show is like the chat feature. And this chat feature is available in the playground so that you are able to interact with the parsing results and see the values on how we can like ground this information in the downstream applications that you have built. Till this is processing, I will show you one more example of an accident form, which also has a very complex layout. This accident form has multiple chunks about the accident itself, but then information about vehicle A, which is like in this order, then information about what happened in the accident itself, which is present in the circumstances as well as through these figures. And then the information about vehicle B is written on the other side. This is a common European accident form, and it can come in multiple different formats and layout as well, not just this one. But for this layout specifically, we chunk every information separately, and then we order them in the way that it all is connected. So like vehicle A, this is the 8th chunk, then the next chunk is 9th. So the way we order it is like it go down and then go up and then go down as well. So it's able to maintain the information that all of this information is related to vehicle A. So when you ask these questions inside chat or extract, you should be able to connect this information clearly. Generally, it takes about 8 to 12 seconds to parse a single page from our API as well as from the playground. This is the same image that I was trying to parse. It's detected as a one whole table. And then all the values are being extracted in the correct cell. This is actually a very good example to show how we are able to extract really large tables and also very numeric tables. If you were to pass this with an LLM, it's a next token prediction, and so it won't be able to provide like the right layout and understand the layout before trying to extract the values from it. We have seen that the number values are mismatched when you parse this with an LLM, and the layout itself has an issue of detecting some of the rows and columns. Let's go to chat. So this chat is available in the playground, and what we can extract is like ask some questions here and see how it is able to find the information from the document and how it is able to ground it. So I will ask something like, what is the total cash value at age 65 for each of the 3 policies? So it's trying to find the total cash values for each policy for the age 65. Once I send this, it gets the information from our parse results and provides the answer here, but also provides like the grounding from where it got the answer from. So for example, for age 65, the total cash value for policy 1, it found the information from this particular cell, and we are able to like ground for any of these tables, like very complex tables without grid lines, scan tables, etc. We are able to ground this information clearly up to the cell level. This is the information that it found for policy 2 and then for policy 3. I will stop here and take some questions. Adrian?
We have a couple of questions here. How do you get this to comply with GDPR?
Yes, correct. So I will come to explaining about the security options that we have, but we do have EU hosting, and EU hosted solution is GDPR compliant. We have the same exact features in our EU hosted APIs as of US hosted APIs.
Excellent. This was answered by Andrea, but I'd like to post it to the group. Why is this better than Azure Document Intelligence?
Yeah, it can be manifold. And I will also let Andrea add to this. One of the things that we have is the layout detection, as I mentioned, which works out of box. So you do not need to worry about what kind of format the document comes into. It should be able to detect every of this layout and then chunk it accurately, and then provide like the captioning or the transcription for each of the chunks. What that does is like your information is structured and correctly ordered, so that you have like much more semantic and enriched information for anything that you do downstream. We are also able to process very complex tables, and also, as I showed, grounded to the cell level, which will provide like additional audit trails and source of truth when you are dealing with like large amount of documents and data.
We have more great questions, but let's go continue with the webinar, and then we'll take these up towards the end.
What I showed till now was parsing. Parsing means extracting and like getting all the information out from the document. But we also have a feature called extract. And I will go to extract. So what we have is, let's go to our digital form. We also have a feature called extract. And this extract feature is where you have a specific information that you want to extract. If you already know what you want to extract from the document and then structure it for any kind of analysis or like storage downstream, we will also be able to provide like just the answers that we are looking for from the document, and then provide all the grounding along with it. So let me like start for this example, the accident form itself, and clean it up. So here you get like some of the suggestions from our AI. But if you already know what you want to extract, you can just start from scratch. When you start from scratch, you can start by defining the field that you want to extract. Let's say I want to extract date of accident. And right now I will maintain that this is a type string, which is like it should be text. And I can provide additional description if it is not clear what the field name is. So date, when. And this description is really helpful if you have like a field which has different names across documents, so you can provide like more descriptive way of understanding what this field could be. Once I have written this down, I will run the schema. And as I ran the schema, it gave me the output of what the exact date is when the accident happened. And when I clicked on it, you can also see where exactly it referenced the date from. So this is the date of when the accident happened, and it's able to find that date and reference it right inside the document. You can also do it programmatically. So when we output this via the API or the code, we give you the data, the answer of what you were looking for, but we also provide some metadata wherein you get the references of each of the cell where this information is coming from. Okay, yeah. And then we can try some more examples. For example, let's say that if you want to have this format of the date of accident into date, you should be able to assign that as a format and rerun it, and it will be always formatted as a date. Let's try something else. For example, I want to get what's the name of the insurance company for vehicle A. I know that like it's the information is further away and it's like a bit disconnected, but I should be able to get that information out just by our layout detection and ordering. So I will write something like insurance company A as the field name, and so it's able to find the insurance company for vehicle A at CTA Insurance, and it's able to locate that inside the doc. I will show a more detailed extract schema. So I have built a schema with various different object types, data types. So for example, this is more of vehicle A information. So I will use the type object and then write down like what exactly I'm looking for vehicle A. Similar for vehicle B. It can also extract information from figures. So if I'm trying to extract the damage summary, like what happened and what is the damages to the vehicles. If I have like initial impact A, like what happened, what was the initial impact to vehicle A, it's able to find that information from the figure which is associated here and then like pointed where the impact happened. Similarly, for vehicle B, it's able to find the information from both this figure as well as this text on where the impact happened for vehicle B. It should also be able to like reference every chunk which it used to find the information. Then I have used numbers for telephone number as a format. I have also used a choice, multi-choice or single choice option. So enum is for like choosing from one of the existing options that I have provided. For example, here I'm using the enum for country where exactly this accident happened, and it's able to locate it to the right chunk as well as select it from the options that we have provided instead of providing what the users have written down. The user has written down CH here, but that means it's a Switzerland in a country code. It's still able to find that from what the options that we provided. So in this way, you can transform the data as well from the coming out of the document and then structure it in the format that you want for the downstream applications that you have. It can have also like Boolean, which is like if it is signed, is it true or false? Because these documents are signed by both vehicle A and vehicle B, I have just asked that question and provided a Boolean format. It's able to also extract them correctly and then say that, yes, both of them are signed. Once you build a schema here, this is actually very helpful to build and iterate on the schema. But once you have built the schema and you want to actually scale it and process multiple documents through it, there is directly the code here. You can access this code and use it with our library and API. I will go into documentation soon, but it provides like for the library, we convert all this schema into a Pydantic class and provide like exact descriptions that you have provided as well as the data types that you have provided in the playground so that you don't need to build it on your site via code. You can just copy this code and get started. You can also download the schema for you if you want to try multiple times, etc. After that, let me show you some more examples of how to get started with the API. First, I will go into like what exactly we have in terms of our APIs. Currently, we have parse API and extract API. We are working towards more APIs, which will come out soon. But for now, we have the parse API. What it does is like it takes a PDF or image or Excel sheet or docs as an input, and then it will output the markdown file, a clean machine readable markdown file, as well as structured JSON, where you have every chunk or every layout that is detected, as well as the bounding box or the grounding for all the chunks. This was parse API. What it will just do is like convert the document that you have in like, and all the information that is logged inside document into a more machine readable format. And then we have the extract API. This extract API can take the markdown that the parse outputs. It can actually take any other markdown if you have like you have processed it through your other systems too. And a schema, like schema is what you want to extract, what exactly are the structured fields that you want to extract. And it outputs response in a JSON format where you have the values, the keys that you are looking for, the schema that you are looking for, and the values that was found from the input document. It also provides like metadata of like how you can reference it back to the original document that you provided in parse, how you can reference it back directly to where the location was inside the document, the original document itself. It can take this extract API, you can use the same markdown and can send multiple schemas to extract like different outputs as expected, so that you don't have to parse the document again and again if you have multiple schemas to be run on the same document. We have a very extensive documentation that you can go at docs.landing.ai. You can easily also go from API docs here in our playground to the same quick start guide. You can get started by like using the example codes that we have to quickly start parsing and extracting from documents. But we have very extensive documentation on how you can use Python library further, how you can reference the visual grounding that we provide back to the document itself, and parse with multiple like local files, remote URLs, etc. We also provide more information on like what we mean by chunking and what kind of different chunks that you might be able to use. How do we provide exactly the grounding and how you should be able to use it. For extract itself, we provide like different versions. We have model versioning for both parse and extract. So you should be able to define the version of model that you want to use from us. If you're willing to take all the new upgrades, you can point it to latest, and so you will get all the new upgrades as they are coming out. But if you want more stability, you can point to an exact model from which you want to process these documents. We also provide some best practices on how to use extract and how to define your fields as well as descriptions. And we have like multiple of language supported. You should be able to find all the languages that we support here. We have the parse API, as I mentioned, to parse and extract all the information from the document. We have extract to extract only specific information. And then we have parse job. If you have like a large amount of data to be processed or a really large file to be processed, we recommend you to use parse job, which is able to work with our rate limits and then make sure that the document is completely processed and output correctly after it is done. I will pause here if there are any questions.
Yes, there are some great questions that Andrea answered, but let me pose them now just for the general audience. Can you share some of the accuracy results against other OCR solutions versus LandingAI?
I would say that we are working towards a benchmarking and external benchmarking for different solutions across different solutions. But for now, what we recommend is you test out with your own documents. What happens is that like the benchmarking is very tricky. We have like multiple different models involved and different steps involved in getting the right answer from the documents of whatever right structure you are looking for from the document. And we cannot really truly compare against any other solution. It will also be an injustice to the other solutions too, because every solution works in a very different way. And then the output, even though this is correct, it could be correct. It can be outputted into different formats. It doesn't mean that if the order is slightly different, it's completely wrong. And so it's best to test it with your own documents and see how the output works for your own documents.
Great answer. Thank you. Can you tell us how you apply rules to the extracted data and how to add it to a business-specific database for use later by additional AI agents?
I'm sorry, can you repeat the question?
Absolutely. And Andrea also answered it with some additional information. But can you tell us how you apply rules to the extracted data and how to add it to a business-specific database for use later by additional AI agents?
Yeah, I hope Andrea answered with like the documentation for extract. If you have extract, you will be able to like describe what exactly are the rules you are looking for in the description of if you have extract, you will be able to like define what you're looking for, the field name itself, but also like any kind of rules that you want to add on top of the extracted results, like what exactly you want to extract, so that it can be transformed and outputted in a structured format, which you can store in a database or use it with other AI agents downstream.
Excellent. Another question. Can you shed more light on how do you provide visual reference?
So let me go to parse again. So in parse, when you go to the JSON, we output a JSON and markdown. Inside JSON, you have the chunk information. So this is the first chunk information. This is accident statement. You will have the markdown for accident statement. Then the classification, the text, it's of type text. Then ID. This ID is super important for you to like use it with our other APIs like extract and any other APIs that are coming out to make sure that the grounding is like to the right place in the document. And then there is a exact location, normalized coordinates of where this bounding box is present inside the document. And also the page information on which page this information is present. If you have like a table where like such as this one, and you go to the JSON, you not only have the location of the table, but for every table cell, you have the location of every table cell. Sorry, this is a really large table. Yeah, so if you have the table, it has the information about like the chunk of the table as well, but also every single cell that is present inside the table. So you should be able to find the table ID, the cell ID, and then what is the value that is present inside the cell ID. For example, in the second cell, there is the first cell ID, there is policy 1 is present. And so you will be able to find all the IDs correctly inside both the chunks, like text chunks, figure chunk, etc., as well as table cell chunks. And then based on those, when you do extract, what we output is the values of the values, and then an exact location, a reference ID, which is present in the parse. So you should be able to go back to what exactly was the chunk this ID is being referenced at inside parse, and get the results or get the grounding or bounding boxes from the parse. And we have very easy code to get started with all this grounding. It's present inside the Python library code. Yeah, and here it's like understanding the grounding dictionary, and how you will be able to locate the groundings.
I think that's good for questions if you want to continue.
I will dive deeper into how you can get this to production, and we can start with the deployment options for this. We have ADE Cloud, which is hosted by us. It's a multi-tenant cloud. We heavily recommend you to use this to at least get started. This would be the fastest thing that you can start working with and seeing results on how your documents work. This solution has a lot of security options present, and I will go dive deeper into them. It has SOC 2 Type 2, HIPAA compliance, zero data retention, and 99% uptime. So you will rest assured it will be the documents that you have will be protected correctly. But it will just get you started with processing the documents and seeing the results, and then start building your solution as soon as possible. If you cannot work with multi-tenant cloud, we have VPL, Virtual Private Link, which is a single tenant SaaS. It's still hosted by us, so you don't have to manage any kind of hosting, LLM implementation, or scaling, etc. But it's separately present for your own solution. This should take a while to implement, and is available for enterprise customers. But yeah, we should be able to do this, as well as VPC, which is Virtual Private Cloud, where you completely host the solution, including our models, as well as any LLM that is being used inside our product. For VPC itself, it's completely managed. We are able to offer VPC in the AWS, Azure, or GCP, and it has full tenant isolation. You should be able to bring your own LLMs here, since this is an agentic flow and it works with wide variety of cases, and LandingAI's foundation model are able to handle different aspects of the extraction. The LLM part we use should be able to work with any of the LLMs that are part of any of these cloud solutions. It will take some time to the implementation. And so if you want to use VPC, but you want to start testing, maybe you can redact some of your documents and then start testing with the cloud solution until you get the VPC. In terms of security for the cloud solution itself, you can go to our 2 trust portals. We have a trust center, and then we have a very extensive documentation on security and compliance for your legal teams. You should be able to see that we are SOC 2 Type 2 compliant, we are HIPAA compliant, as well as GDPR compliant in our EU hosted solution. For the cloud solution itself, we also have zero data retention, and you will be able to find more information about zero data retention. What it means is that we don't store any of your documents, any schema, or any results from your processing. This is available for subscription users. And it is an extra credit for us to implement ZDR solution. Once you have ZDR, we are not even able to access it for even parse job. So you should be able to complete a parse job without it being stored, with just providing the link of where the document is present. And then the last part that I wanted to touch upon is pricing, which goes directly with the deployment solution. We have pay-as-you-go to get started. We have about 300 pages that you can get started for free to just test around. But then you can just get started with pay-as-you-go as you are building the solution and making it production ready. And then we and step-by-step plans So you can meet your needs starting at $250 a month. And from this plan itself, you should be able to use zero data retention and HIPAA compliance with VA sign agreement from us. We also provide extensive discounts as you go above in tiers, as well as rate limits increase. As you go for annual plans, we have further discounts on this. The solution is almost similar for all the tiers, starting from pay as you go. You get like the layout detection, field extraction, everything starting right from pay as you go. That's all from my side. I'm really thank you for taking time and listening to our product.